Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Welcome to Lady Khadija radiallahu anha online college live lesson, A-level maths year 2, pure maths. Today's lesson is on trig equations, chapter 5, example 18. This is actually a second repeat of one of the lessons, but we'll take it from scratch. Okay, Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Let's pull off a trig equation. If you're following through in the exercise in the textbook, it's the edXL Pearson UK A-level textbook. It's example 18. So we have to solve this equation, and we're given an interval in radians, so that means we're going to have to be working with the angle in radians. Remember that 2 pi just means 360 degrees. Let's rewrite the equation. There is a slight mistake in the textbook, but let's fix that. So it's not 2 sine squared theta, it's supposed to be 3 sine squared theta is equal to 13. Let's put in the theta and the squares. Notice now that I've got an equation with cos theta, and then a bit later there's suddenly a sine squared theta. The fact that it's sine squared isn't the problem, but the fact that it's a sine and the other one's a cos, that's a problem. You need to make them the same. You can't have one cos and one sine. So the best way to change this is, remember, sine squared plus cos squared theta is equal to 1. You're going to need that a lot in these kind of questions. So start with that and then say to yourself, well, that whatever is the squared term, here the sine squared term, let me try and get rid of that. So let's rearrange this for sine squared so that we can then use it to get rid of the sine squared. So let's rearrange this for sine squared. So plus cos squared, theta can go to the other side. The plus can become a minus. So I've got sine squared can be replaced with 1 minus cos squared theta. So let's do that swap. So I've got sine squared theta can be swapped with 1 minus cos squared theta. I'm going to need to put brackets around that because there's a 3 on the outside. So it's exactly the same question, but I'm substituting sine squared theta for 1 minus cos squared theta. And now we just want to expand out those brackets. 17 cos theta can stay as 17 cos theta, but then the rest needs to just expand out. You got 3 times 1, that's 3. And then you got 3 times minus cos squared theta, so that's minus 3 cos squared theta. And that's equal to 13. That doesn't change, that's the same. Then let's try and simplify a little bit. You've got plus 3 here and then 13 here. So let's take the plus 3 across, and that'll be a minus 3. The 13 minus 3 can just make 10. And then what you notice, if you look carefully, is that this is just like a quadratic. Imagine this was something like 17x minus 3x squared equals 10. That's a quadratic. It doesn't look like a quadratic because the cos theta is making it hard to spot that. So what we're going to do is a little trick that you probably use quite a lot when you're dealing with these kind of equations. Cos theta, we're just going to write as c. So let's just simplify it down. So if cos theta we're going to write as c, then cos squared theta we're going to write as c squared. And equals 10 stays as equals 10. Now it's written like this. It's just easier to recognize it's a quadratic equation. So let's make everything equal to 0 and get the 3c squared positive. So let's swap all the signs. That can become a minus, that can become a plus, and that can become a minus. Then let's make it equal to 0. So the minus 10 can come across, and that'll be a plus 10. And remember with the quadratic equations, especially if you're going to be using a calculator to solve them with the quadratic equation function, you want to make sure that it's lined up so that the squared power comes first. So we want 3c squared to come first, and then the minus 17c to come after that. So it's in the highest power first. The plus can disappear. So now I've got this quadratic equation. If you're used to using a calculator to solve these, you've got a function on your Casio calculator or whichever calculator you've got to solve this. So you just type in the equation and it will give you the answers. Here we're just going to factorize. So let me just try 3 and 5, 3c and c and 5, and let's go with plus 2 and minus 5. So I've just factorized it. Hopefully that will work. Let me just double check. That's 3c squared minus 15c plus 2c isn't what I want, and minus 5. So let's change that plus 2 to a minus 2, and that should work now. And then for each, then you've got two solutions. The first solution is 3 over 2, that's 1.5. And the second solution is 5. Remember, c just meant cos theta. So I can now put that back in. Cos theta equals 1.5 or cos theta equals 5. And remember, we're going to be working in radians. So I need to inverse cos each one separately. The 1.5 will probably be fine. I think that was a mistake, sorry. It was 2 over 3, not 3 over 2. So that's 0. Just write 2 over 3. So the calculator should be able to give you an answer for that. If you do inverse of cos and then type in 2 over 3, the 5 will give you an error, so there's no point putting that in. Let's give you the answer for this one. So we'll grab a calculator. You can do this as well on your calculator. Make sure it's in radians mode and type in inverse cos of 2 over 3 of 2/3. On this calculator, I'm just going to do it slightly different. Radians mode is there. Type in 2 over 3 and then inverse cos that. And that gives me 0.841. 0.841. So I can say that theta, my first answer for theta is 0.841. But I need to keep going because normally with sine and cos equations, there's multiple solutions. So if you go back to the interval, we need to keep going all the way up to 2 pi. The way I get my second answer is I remember that for the cosine curve, to get the second answer, all I need to do is start with 2 pi and then subtract my first answer. So 2 pi subtract my first answer of 0.841 will give me another answer for theta. So let's try that. 2 pi and then subtract 0.841. When you're doing it on your calculator, you want to use the exact answer. This calculator is a bit simpler. It doesn't hold the previous answer, so I'll just work with that. So 5.442 is your other answer. Theta equals 5.442. And you can round to three significant figures, so normally 5.44 would be enough. Write the full answer first in your exam and then round after just to be on the safe side. Okay, thanks for following this. A little bit long, but make sure you just use the technique at the beginning to try and think, how can I make, instead of having cos and sine, two different trig ratios in the same equation, think how can I make them match. Normally you go for the sine squared plus cos squared equals 1 as the one you're going to change. So you rearrange that, swap it for the sine squared, and that'll become 1 minus cos squared in brackets. Expand, simplify, get it into a quadratic form, and then just type it in the inverse cos into your calculator. Join me for more on equations with trigonometry and radians. Assalamu alaikum wa rahmatullahi wa barakatuh. Peace be with you and the mercy and blessings of God.